Welcome to Chapter 9, C-Formatted Input and Output. I will rush you through this chapter because you already know like at least half of the material in it. Also, we'll be focusing on C-formatted output, not so much on the input part. So this chapter is mostly about greater details about the conversion specifiers you've been using, those %d, %u, %f, and all those converters. So let me jump through to, because you already know much of this, I am going to jump directly to the new, additional, and more interesting part here. So we keep going. So you're already familiar with these. You've been using %d to output decimal integers. There's another conversion specifier %i that you haven't used that we, however, use sometimes with the scanf function. O for octal integers, U for unsigned decimal integers, X for hexadecimal integers. There's a difference between the lowercase x and the uppercase x, and it's really just this. If you use the lowercase x, the alphabetical digits A through F will be lowercase. If you use the capital X version, the alphabetical digits A through F will be the capital letters. That's the only difference here. Then there are some length modifiers that you can use together with other conversion specifiers, and you've used L for long and LL for long, and H is for short. And so in this chapter, I'll show you primarily implementations, demo codes, lots of them. And for the hands-on section of this chapter, I have combined most of these into a single program. And that'll give me the opportunity to show you another function that you might find useful that we haven't used so far. So there's a whole lot over here. So this is the first printf statement, simply prints a decimal number using %d. So pay attention to the conversion specifiers. %i also prints the same as a decimal number. You can even provide the number that you want to print with a positive sign, makes no difference over here. You can provide a negative number that will automatically, of course, display the negative number. 32,000, this is a number that falls in the range of a short integer, so hence the use of the length modifier h. Then we have a larger integer of type longint, and to specify that this is actually a long integer, we add a capital L at the end of that number. And we use the LD conversion specifier for that to print out the same number as an octal number. Use O. And you've used this in one of your assignments. To print out a number specifically as an unsigned integer, use %u. But if you pass the same number as if you pass a negative number and try to print that out as an unsigned integer, well, we'll see what the output for that is. It won't be for 455. And you can print out 455, the decimal number, as a hexadecimal number with lowercase alphabetical digits, or 455 with uppercase as a hexadecimal number, but uppercase letters. And here's the output from this program. So this over here is interesting. This is us printing the number minus 455 as an unsigned decimal number. So that causes a problem, as you can see. As for the rest, whether you provided a plus sign or not, as long as you're dealing with positive numbers, by default, you will not see a plus sign printed out in front of the number. And here you see the difference between hexadecimal numbers printed with percentage lowercase x versus percentage uppercase x, a lowercase c and an uppercase c. Then let's talk a little bit about conversion specifiers for floating point numbers. So we've already used a conversion specifier percentage f, but there are some other options that we have. So another way to display fractional number is the scientific notation, meaning something like this. Correct? So on paper, you would display it like this: 1.504582 into 10 raised to power 2 in this case. Now, on a computer, we do not have superscripts, not on a console at least. So the same number would be displayed like this. So x, so multiply by 10 to the power 2 is displayed here as e plus 02. The plus just clarifies the sign of the exponent, and e stands for exponential, stands for 10 to the power something. There are some variations here. So you can use a lowercase e or an uppercase e, and really all this is just cosmetic. All it does is it changes whether this e that you see printed out over here is a lowercase or an uppercase e, kind of like the difference between printing out a hexadecimal number with a small x or an uppercase x in the conversion specifier. We can use, so we're already familiar with the use of f as a conversion specifier, and then there's another new one, g. Now what g does is it basically, leaving it up to the computer, up to the compiler, up to your program actually, to decide how to best display the fractional number that you have, whether to use the exponential notation or whether to stick with the with that decimal format that you get when you use the f conversion specifier. And also capital L placed before any floating point conversion specifier to indicate that a long double floating point value should be displayed. Okay, so let's look at some examples. Oh, and by the way, we have two versions for the G specifier, G lowercase g and uppercase g. That is in case the representation for your number is chosen to be exponential, it'll use the uppercase e for that. And let me show you some examples for that. And here we have clearly a fractional number with a lot of digits before the decimal point, printed out using e, and this number is displayed like this with a small e over here, lowercase e. Now you can add a positive sign here or a negative sign over here. If the number is positive, still no positive sign is shown over here. If the number is negative, obviously it'll show and display a negative number. This is the output with an uppercase e in the conversion specifier. So it makes the e over here an uppercase e. If you just use a regular f, get something like this. That's a regular decimal number with, by default, 6 digits after the decimal point. And then if you choose lowercase or uppercase g, in this case, for this particular number, the system chose to display it in scientific notation with lowercase g, meaning lowercase e, uppercase g, meaning over here uppercase e. Okay, this is displaying characters and strings. We have done a lot of that already, so I'm not even going to talk about that. Then there's pointer formatting. We've already used that before. Absolutely nothing new over here. This is used to display memory addresses if needed. Remember, %p. Another comment, if you want to print a percentage character in a string like this one over here, you have to put 2 percentage signs, one after the other, to tell the compiler this is not a conversion specifier that you're printing out over here, where you forgot to put a D or a U or an F after that. Instead, what you're actually trying to do is just print a percentage sign. So you have to put 2 percentage sign in the string for that. Kind of like an escape sequence. Okay. Then you can print out numbers specifying the field width, like how wide, how many characters long, how many characters the number should take up. So over here, we're printing out initially a 1, 2, 3, and 4-digit number, all as with a field width of 4. Decimal numbers, but we're saying there should be they should be allocated 4 digits on the screen. And then we try printing out a number that is 5 characters long, but we are allocating it only 4 characters, a width of 4 characters. And then we do the same thing with negative numbers, still providing only a field width of 4. And the output for that is going to look something like this. Although on my system, the output is a little different for this one number over here. But you can see that all numbers are right aligned. But when the number starts exceeding the field width, the digits start spilling over across that boundary. And the same thing for negative numbers. Field width is 4 characters, and when the number to display gets longer than that, the digits start spilling across that boundary. This is about precision. Again, this is something we've done for quite a while. We can specify the width of the number, and we can specify the number of digits after the decimal point. Now you've seen that numbers, when you specify the field width, are right justified, are shifted to the right. If you want to have them left justified, you can do that too. You can add a minus sign. Now, adding a plus sign to the conversion specifier does not automatically mean right justify. Instead, it means that if a number has a minus sign in front of it, show the minus sign, that already happens. But if it's a positive number, display the plus sign as well. If you leave a space, yes, that also has a meaning. If you leave a space in the conversion specifier, it means if you have a positive value, do not print a plus sign, but leave a space character instead. If you add a hash inside the conversion specifier, it adds a 0. It prefixes a 0 to the output value. When used with octal, it'll prefix a 0x or 0 capital X, depending on what you're choosing, if you're printing out a hexadecimal number. And if you're adding a hash to a floating point number, it will force it to add decimal point after the number if there isn't one. if you add a 0, that will add leading zeros at the start. And you can even specify how many, up to make the number into how many digit number. Remember, in the very early on in the course, showed you the example where I printed out a 7 as 007. That was me using this modification to the conversion specifier. So in this example, I'll demonstrate how to left align and right align text. So over here we have a bunch of things. So first we print out a string that helps us count the number, the position of a character. So the first character will be position 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 0 here stands for 10. And then we have 11, 12, 13, 14, 15, 16, 17, and the next 0 means 20. And then 21, 22, 23, 24, 25, 26, 27, 28, 30. And finally, the last one is character number 40. So this is just, I'm printing out this row over here just for us to make it easy to count the positions of what I'm printing in the next 2 lines. So we're printing a 10 character string, hello, and we'll see what that looks like. Well, the string is automatically right aligned. Then I print out the integer number 7 as a 10-digit number, and what that'll do is it'll right align this number, leaves 9 blanks over here. I print the character A again as a 10 character, and that leaves 9 blanks, 9 spaces in front of that, and then a floating point number 1.23 also as a 10-digit number, and that leaves 6, 7, 8, 2 spaces over here. Then I print out these same values, but this time I want to left align them. They're still being printed out as 10 character field in 10 character wide fields with a field width of 10, but now I'm aligning them to the left, and I achieve that using these minus signs over here. And you can see the output, hello, is left aligned. 7 is left aligned. The character A, left aligned in its field. And the floating point number 1.23, also left aligned. So in this row over here, everything is right aligned. In this last row that I'm printing, everything is left aligned. I think. Okay. Yes, so then there's printing out numbers with the plus flag. So I have 2 numbers that I'm printing out, a positive number and the same number with a negative sign, 786. The first time I'm printing them out just with regular decimal number conversion specifiers %d. The next time I'm adding the plus sign into each conversion specifier and see what the output is. When I print out the positive number without the plus sign in the conversion specifier, just shows up like it always does, left aligned as a simple unsigned positive number. The negative number displays with the minus sign, of course. But when I do the same thing, but add the plus flag to the conversion specifier, 786 prints out with a positive sign, with a plus sign. Then there's a space flag. So let's say I have 547 and minus 547. I'm printing them out with a space left in between the percentage and the D. Percentage and the D. When I print these out, 547 prints out without a plus sign, but it leaves a space over here. Minus 547 is printed with its sign, its negative sign, of course, but you can see the effect that this is a way to align numbers to look more neatly. And then there is the hash flag. Octal values will be printed with a 0 in front. Hexadecimal values will be printed with a 0x lowercase x or a 0x uppercase x in front of them. And if you have a floating point number, it'll add a decimal point at the end. Let me show you as an example over here. So we have this integer C, 1427, printed out as an octal number with the hash flag. It prints out with a 0 in front. Printed out as a hexadecimal number, it prints out with a 0x lowercase x in front. And with the hash and the percentage uppercase x conversion specifier, it adds a 0 uppercase x in front of the number. Print out, add the hash to the percentage G conversion specifier, and it adds some decimal digits after the number. And you can combine some of these like this. So this over here uses the plus sign to add a plus sign to the number, adds leading zeros, and makes the number 9-digit number. So you can see over here, we have a combination of flags. We're still displaying a decimal number 452. And without the plus flag, the same thing will show up like this.